Hey guys, just wanted to explain what you need to do for the test review so that you can get that test grade fixed, but hopefully you put in some time to hopefully try to understand the material better than you got now. And that's the whole attempt of these videos, is for me to maybe have a different discussion with you that can probably put some of the pieces back that you're missing right now. So please take this correction serious and go through these videos when needed, and make sure that you do the test corrections on your test, on your actual test. Make sure you watch these videos for the problem numbers that go over, give you a good explanation. Take notes. Okay, when you're done with that, show Mr. Bowers your corrections. We're going to have a little chat about what you weren't getting about the material, all that. Just make sure that you're okay, and then hopefully these videos can help you with that too, and that would be awesome. And then let's set up a time that you can come in. I do want you to take the retake in my room. So anyways, let's go over the first set of problems here, this 1 through 7. So I'm going to capture this here. Okay, so let me explain what's going on here. Just so you know, the problems 1 through 4, I put on the retake test. These ones, I want you to be able to do those. You guys should be able to evaluate functions, and hopefully this will make sense of what that means. 5 through 7, I'm going to explain what those questions are asking, but I don't expect you guys right now to be able to solve those or answer those questions. So anyways, for the test review, you'll get evaluating like 1 through 4, but I'll explain what 5 through 7 is, okay? So what it says here in this problem is we have two functions. One function we're going to call f, the other function we're going to call g. And all the functions are, guys, are just number patterns that tell us what to do to a number. So like for f, for example, it says whatever we let x be, we're going to square that number, right? And we're thinking about order of operations. Please excuse my dear Aunt Sally. Remember that? Parentheses, exponents, multiplication, division, addition, subtraction. So we follow those order of operations as we evaluate. We're going to take a number in for x. We're going to square it, right? And then whatever we get for that squared value, then we're going to double it. We're going to do multiplication after exponent, right? So square the number that we put in for x, double that value, and then we're going to subtract 3. Whatever we get out is our output, and that's what these expressions are. F of 0 is just saying this expression is the output after you put a 0 into f, right? And so we'll run that through here. And really all that you do, if x is 0, right, that's what this notation says, in the parentheses tells us what our input value is going to be. So we're going to put a 0 into f. 0 squared is 0 times 0, which is just 0. 2 times 0 is also 0. Doubling nothing is still nothing. And then we take away 3, we get out a negative 3. So f of, it's a horrible negative 3, f of 0 is negative 3, okay? And then we would do that for the other one. This says that in the f function, we're going to put in a negative 1. What do we get out? That's all that this is going to be, okay? So these notations, these are for outputs, okay? And we'll talk more about that in class. So here's what I wanted to put a visual to what those problems are. I have this app right now. It looks kind of crazy. It takes two functions, an f function and a g function, and then I have points that I can slide along those functions. And what they tell us, remember, the whole point of tables, the whole point of graphing is so that we can compare input values to output values, right? So here's an example of an f function. I'm going to make g go away. I'll make it the 0 function, which should be a straight line where y is 0, right? Our outputs are 0. So here's this red function. It just happens to be 2x plus 1, and so my point is sitting at 1, 3, which means we put a 1 into our function, we get out a 3, right? Put in a 1 on our x-axis, get out a 3 on our y-axis, right? So as we move that around, those crosshairs stay with the point so that we can see the input at that point and the output relationship, right? So let's say, for example, we put in a 2. So if we put in a 2, we would expect to get out a 5, right? And look at this function. It says put in a 2 for x, double that. 2 times 2 is 4. Add 1 to it, and we get out 5, right? If x is, say, a half, or even the beauty of functions, guys, is it allows us, if we know how to explain the pattern, we can evaluate not nice numbers, right? I know, because that points on my function, that if I put in a 1.28, I'm going to get out 3.56, right? Okay, so let's make f the actual f function that's on it. So f is 2x squared minus 3. Okay, so 2x squared minus 3. Take a number, square it, double that number, and then take away 3, right? So now I'm going to graph f, and it's a quadratic, right? It's an x squared. We're squaring a number, so it's going to be this parabolic shape, this quadratic graph here, okay? Which we need to talk about too a little bit more in depth. But for now, let's evaluate f of x when at 0, right? So what that means is when we put in a 0 into our function, notice we get out, we can get that on 0, we get out a -3, right? And that's exactly what we said we were going to get out when we evaluated that. F of -1 means, if I look at the graph, if I had a graph like I do now, if I look at where f is, or x is -1, that's our input. Notice our output is a -1, right? -1 squared, by the way, -1 times -1, +1. +1 times 2 is +2. +2 minus 3, there's our -1. Okay, so if we have a graph, the graph tells us evaluation, output values at given inputs, and also what input values give us outputs, and that's what the questions 5 through 7 are asking, okay? But let's take a look at this. So we said that f of -1 is -1, right? Got that from the graph. We also just evaluated it real quick. Okay, 2 and 4 are taking the g function. So I'm going to go back to this graph. I'm going to hide my f function, make it that 0 line. G of x is now, what do we got? 3 times 2 raised to the x minus 1 power. Okay, so I've got 3 times 2 raised. The power is an expression that's whatever we put in for x, we're going to take away 1. So I want to make sure that I keep that in parentheses, and it keeps that power together here. So 3 times 2 raised to the x minus 1. So when I hit enter, here's our 2 to the x function, right? It's that exponential function, and all exponential curves kind of look like this. They just, the shape a little bit will change depending on what number we're raising to a power. So it's saying here on number 2, let's evaluate at 3. So I'm going to take my point here, and I'm going to put it in. I'm going to move my graph. Oops. 1 second. I'm going to lock these points in place real quick. Okay, so now I'm going to move my graph here, and so I'm going to evaluate this at 3, so I'm going to let my x be 3. So when x is 3, notice we get out a 12, right? This b point is for the g function, that a point was for my f function. So this says that when we put in a 3, we're going to get out a 12, right? And we can see that from the graph. So we put in a 3, and notice that output that corresponds at that point is 12. So let's check this out here. Order of operations says parentheses first. So if we let x be 3, we're going to put in a 3, take away 1, so we get 3 minus 1 is 2. So now we're taking 2 raised to the 2 power, or 2 squared, which is 4, 2 times 2. And then 4 times 3 is 12, right? So there is our evaluation, right? And then also the last one, g of 1. So g of 1 says, let's evaluate at 1. Let's let x be 1. So if we put in 1, we get out a 3, right? So if x is 1, 1 minus 1 is 0. Right now we have to understand that anything to the 0 power is 1. Let me show this here. So if we're going to take 3 times 2 raised, let's let x be 1, 1 minus 1 power. So what we get is 1 minus 1 is 0. So we get 3 times 2 raised to the 0. Right now, just understand anything to the 0 power has a value of 1. We'll explain that later. So we get out a 1 here, and then we take that times our 3. So 3 times 1 is 3. Okay, so 5 through 7 just says, if we look at our f function again, make it this 2x squared minus 3. And if we get out a -1, what x value did we have to put in? And actually, we already know that one. We know that if we get out a -1, we put in a -1. So x has to be -1. G of x says if we put in a 3, and actually I guess we have those questions. If we got out a 3, what input did we have to put into G to get that, right? So if we got out a 3, we must have put in a 1, so x is 1. And then the last one, f of x equals 15, what is the value of x? So we don't have that one already solved, but let's look at our graph here. So I'm going to graph f, again, 2x squared minus 3. So let me hide this one. 2x squared minus 3. There's our f function again. So what it's saying is what input value, what x value do we put into f so that we get out a 15, right? So I'm just changing my y scale so that I can still look at getting out a 15. So what I'm going to do is I'm going to move my point so that my output is at 15, right? So right here, my output's at 15. So now I can just follow this down and look what my input was. And my input, notice, has to be -3. -3 squared, by the way, if we just evaluate this real quick, -3 squared, -3 times -3, that's 9. 9 times 2 is 18. 18 minus 3, there's our 15. So that's what those questions are asking here. What x value do we put into our f function to get out of 15? In this case, x has to be -3. And we'll learn all sorts of algebraic techniques to solve that without needing a graph. Okay? So anyways, I hope that made some sense, guys, and take some notes and be able to do that on the retake. Thank you.